Good afternoon, everyone. Pleasure to be here with you today. I'm Mohammed Ahmed. I'm working with Electric Power Engineers. I'm leading the energy market analysis with the team. And today, actually, I'm going to touch base a little bit on the FERC 1920. And we are going a little bit with a little bit of intro about the transmission planning or the regional planning in general, and then going from that to focus a little bit about the challenges and actually opportunities with the FERC 1920. So I know it's a new topic, but can maybe see a show of hands if you already heard anything about FERC 1920 before? Okay, good. That's good. That makes my life much easier. So this is basically the agenda. So I will first touch base a little bit, as I mentioned, about the current regional transmission planning overview, and then what FERC 1920 is bringing and why actually there is FERC 1920 altogether. Then we'll focus a little bit about the FERC 1920 benefits definitions, which is a really interesting topic. And then mainly we'll touch base on the ambiguity of some of the those benefits and complexity actually of calculating some of them as well. And then we'll talk a little bit about PLEXOS and how PLEXOS can help to solve those complexities and ambiguity about those benefits. So if we just go through those that are been working in transmission planning for a long time, we went to transmission planning in two phases. So the first phase was basically utilities. They have the right of first refusal. If the ISO come up with a project, they like the project, they will take it. So the first phase we went about was the FERC 1000. So the FERC 1000 actually removed that. So with the FERC 1000, it's a competitive procurement of transmission line. Utilities, they don't have the right of first refusal anymore, which is okay. However, there is a lot of limitations onto that. One of them is it was mainly focusing on up to 10 years. And the things were mainly focused into two things, into either reliability evaluation or economic evaluation. And the economic evaluation here was mainly APCs or adjusted production cost. With that, this was not capturing everything. Like David in the morning and all of the panel speakers, actually, they talked about the same thing. We are in a new era. That era including different loads, different resources, renewables, extreme weather conditions. So the way that we used to plan the system is not going to fly anymore. And FERC, to help with that, they moved for, so this is again, back to the previous slide, and which utilities or ISOs are doing what. So some of them, they're doing reliability planning mainly. Some of them, they focus on economic, and very few that actually combine both. Like, for example, the SPP, DPP window for transmission planning, which is just finished on April 28. So that in that window, you are either submitting a reliability project or an economic project. So it's distinct. And if you find a project that can actually meet some of the reliability needs and the economic needs as well, that would be a good thing. So what is the problem with that type of planning? Is actually that type of planning, there is multiple layers, that there is actually some issues with that. And this is, you can see the slide is the gaps. So what were the gaps that was before the FERC 1920? Those gaps includes that there is not much of scenarios considered. There is also the technology integration, either DLRs or GATS is not considered. So there is a lot of things that the old transmission planning is not covering them. And that was actually trying to be solved under the FERC 1920. So the FERC 1920, we were actually bringing multiple benefits for every project, and those multiple benefits mainly to give the cost-benefit ratio for some of the projects higher value. So as you can see also, there is some other things can be driving the transmission planning process, the uncertainty and the resilience assessment, also the generation transmission and the piggyback between putting generation and putting transmission in the system, as well as the mix between the economic and the reliability planning, and also the public policy. So those are the items that under the FERC 1000, we're not capturing those things. And the FERC 1920 was coming to actually to try to solve these issues. So with the FERC 1920, I would say that there is two main buckets that the FERC 1920 was focusing on. The first bucket is the cost allocation of any transmission line. So the cost allocation, the FERC 1920 was working on how the cost of the transmission line will be socialized between different areas. So this is something very important to be considered. And why is that? Because this is actually can facilitate a lot of the investments. Because if the cost is socialized between multiple entities that actually getting the benefit of the transmission line, that will make the case for more lines to be built. But not only that, because if we think about the cost will be shared, what about the benefits of the line itself? Is it only one benefit or multiple benefits? And what are those benefits altogether? And most importantly, if we name them, how we quantify them. And this is where the complexities will be starting to appear. Because yes, as we will see, we have 7 benefits under the FERC 1920. There is like general definitions for those benefits, but when it comes actually the devil in the details, when you go to the details, okay, how I'm going to quantify those benefits really, that is the biggest question that we would like to discuss for the next couple of slides. And as I mentioned here, the focus of the next couple of slides will be actually how we can bring the gap between what FERC 1920 defined those benefits and how we can implement them using the tools that we have in hand. Okay, so I think we put a lot of starting the scene about the FERC 1920, but it's what is FERC 1920 and what are those benefits? So those benefits are captured, though there are 7 benefits, and those 7 benefits, what you see on the left here, this is actually the notion or the main theme of the benefits. So the main themes of the benefits, they would like to capture these things. They captured the long-term transmission planning, so we were moving from 10 years to 20 years, so that's one aspect of it. We have those 7 benefits that we have to go through. We are permitting or opening the gate for scenario-based planning rather than just couple of high load, medium load, or low load, or high renewable, minimum, low renewables. The cost allocation and the state engagements as well. Generation interconnection and transmission planning coordination, and the GETs as well, which is if there is a GET can help me and make me reach to what I want without building a new line altogether, that's actually will much be helpful for the system and for the ratepayers as well. But when we look at, I will go deeply into each of those benefits in the next slide. But as you can see, those are the benefits on a high level. We can categorize those benefits. The first benefit, that's mainly targeting reliability. And you can think about this benefit if you build your project and that project get the system relieved from thermal overloads, what are those equipments that got relieved? So the avoidance of upgrading the system due to a transmission line, that will be considered as one of the benefits. From benefit 2 to benefit 7, those are more towards the economic side of the transmission line. So benefit 2 is focusing more on the capacity value of the line. And you can think about this if the line helped you not to build more generation. So if I am building a line and that line will open a corridor for a generator that I was not using before to a load that was not be able to met, if that line will open that corridor between a generation that I was not using to a load that I need to serve, that prevent me or help me not to build generators to meet that load. So that's the capacity value. Benefit 3, that's the normal, like the normal ones, which is ABC or the adjusted production cost or production cost saving. When you put a line, if that helped to actually to schedule more cheaper resources than the resources that are going to be scheduled or dispatched without the line, that's saving in the production cost. That's definitely one of the benefits. The fourth benefit, that's mainly related to the transmission losses reduction. So if you put a line, that line helps to redispatch things and reduce the losses. So that's actually the benefit that captured this, benefit number 4. Number 5, that's actually related to changes or reduction in congestion due to outages. So as you can see here, that the system will not be just studied in intact or N-0 or base case and N-1. No, I would like to go to a system, see the norm of the outages that happen in that system, and understand if the line under that stress scenario, how that line can help me. And to continue that concept of the stress scenarios, we go to number 6, which is really interesting, which is the extreme weather event. The extreme weather event is very important because some of the investment decisions may not be actually justifiable under the normal conditions. And I think already from the morning, we heard about the Uri storm that happened in ERCOT. We got a lot of outages. The idea, if we are studying in the planning horizon an extreme case, there is some investment decision may come out of that planning study that would not be justified if we do it at the normalized weather scenarios. And then the last one is also very interesting, that this one is a capacity product, and this is due to the reduced of the transmission losses. So if you look at those benefits from another lens, benefit 2 and 7, those are focusing more on the capacity product. Benefit 1, it's focusing on the reliability value. And 3, 4, 5, 6, those actually energy components. So those are the benefits altogether. And if we can package those benefits, some benefits, which is 1, 2, and 7, 1 is the avoided reliability or the avoided upgrades. Number 2 is the capacity value or the loss of load expectation and the reserve margin. And 7, which is reduced losses. Those benefits, or that group 1, there is a little bit of complexity about the definition coming from FERC altogether. What will be the methodology that is going to be used to capture those, and also the tools. The second category, it's a little bit better, which is 5 and 6. So 5 and 6, the problem there, the definition is clear, but the problem is that for the scenario modeling, what scenarios will be considered. 5 and 6 is one of them related to the outage, and 6 related to the extreme weather. So how you build those scenarios all together. So the definition is clear, but what will be the scenario building, as well as how you implement it as well. And then 3 and 4, those are the most straightforward because we already used them before. With that, every system operator is trying definitely, there is a FERC order, so every system operator tried to comply with this. So I'm putting here just what MISO is doing for now and what SPP is doing for now. So everybody already, like MISO and SPP, they had already their transmission planning process. And when the FERC 1920 came out, actually it came out from already discussions with SPP and MISO and other ISOs as well. So it was a shift from what they have, but they tried to find also what are the things that they can be still used from their previous planning process and that comply with the FERC 1920, and what else, no, it doesn't comply with that and needs something extra. So for example, with SPP, they identified that benefit 2, they identified that benefit 2 and 6, they were not included before in their CPP process at all. So that's why they have internally groups that are working, okay, how we can quantify benefit 2 and benefit 6. With that, this slide, I know there is a lot of text over there, but this slide is doing actually multiple things. It compared between the description that came out of FERC for the different benefits and actually what will be the how we can calculate, or the method that will be calculating the value of that, and how we can actually modernize this one across the benefit, or how to calculate the benefit altogether. One of the things, as you can see here, that we will always be solving the system twice. One with the solution and one without, and compare the difference. And that actually brings a lot of questions now. Those questions I'm going to cover in the next couple of slides. So first of all, okay, are you going to do solution by solution? Like let's say I got 1,000 transmission line solutions submitted. Am I going to do one transmission line at a time? Or I'm going to do portfolio analysis. So I'm going to do a portfolio of transmission and see what will be the benefits. That's one thing. That's a big discussion with stakeholders now. The other big discussion as well is that what would be, so as you can see, there is a base case and there is a change case when you add the line, and you will compare the values before and after. The question that is being asked now, what would be this base case looks like? Because if the base case is based on a lot of renewables, for example, that could direct the investment decision in one direction. But if it's more gas involved in that base case, it can actually come up with a different set of results. So what will be the definition of the base case altogether? And that's actually covered in the next couple of slides. So this one is, are we going to do facility by facility, or are we going to do solution by solution or portfolio based? And the second piece is that what is the base case and the change case looks like. And this slide shows you some options. It's okay. So am I going to do capacity expansion model for the next years, and what this capacity expansion model will look like? If I identified some upgrades needed to make the solvable case, am I going to include this as part of the base case or not? All these details is part of the solutioning of this whole thing, and actually to evaluate the cases with the FERC 1920 before and after adding the transmission line. So this slide is just to introduce a little bit about what is complex about this. And due to the time, I may touch base on a couple of things, which is maybe 2 and 6 to focus on those 2 specifically. So the benefit number 2, what it says actually, it says, okay, what will be the capacity value of a transmission line? So if we talk about MISO approach, for example, so MISO approach would be that, okay, put the line, so there is the base case you have, you calculate the loss of load expectation using their tools, for example, CERVAM. So CERVAM is the tool that is being used to calculate the loss of load expectation. So they use CERVAM, they calculate the loss of load expectation, let's say it's 0.9 day per year. And then they add the line. When they add the line, let's say that 0.9 dropped to 0.8. So it becomes from 0.9 to 0.8 day per year. Now the question would be, okay, this is the benefit of the line. I dropped the loss of load expectation from that value to this value. So what they will do, they will go back to the system, remove the line one more time, and they start adding generators to be able to achieve that 0.8 again. So if you remove the line, you go back to the 0.9, and you start adding generators. The amount of generators that you are going to add, the value of building those generators will be the capacity value. As you can see, there is a lot of things here. First of all, once you connect a line in a system, the definition of the zones of that system will change altogether. Like the definition of the zones in any system is based on the snapshot of the system itself. Once you add a line in the system, those zones actually will change altogether, the concept of the zones as well. So are we going to consider this as part of the analysis or not? So this is definitely a big question mark about that type of analysis. So others also, they are using the value of lost load, and they compare between having the line and not having the line, and they see how much load you are saved using the line, and they calculate that value, multiplied the value of lost load or the vol to provide the capacity value. There's a lot of questions also, is this a probabilistic nature? Does this actually meet the FERC 1920 for the benefit, the definition of the benefit too or not? So again, there is lots of ambiguity on the definition itself and how it can be interpreted actually, as well as what is the methods that can be used to calculate that benefit altogether. When it comes to benefit 6, which is I'm going to dedicate some more time for that specifically, Benefit 6, one of the also most interesting ones here. Because when you talk about the extreme weather events, what type of events we are talking about? So there are so many events that can be considered. And even if we identify those events, how they will be modeled. And are we going to consider them for part of the year or for one event and calculate the probability of that and actually socialize it for the whole year, or how we will do this from a modeling perspective? So that's actually, I will, for the sake of the time, so that is basically benefit 2. And this is what we have discussed. And definitely, it's a good segue when we come to PLEXOS, because the tool that can help us to automate a lot of that stuff, that will be a very, very good tool for us. So as we know, in PLEXOS, we have the PASA model, which is actually can do resource adequacy. And as you can see, benefit 2 altogether, it has a resource adequacy part. And then after the resource adequacy part, you need a generation expansion part as well. So the PLEXOS can actually have both sides of the coin. We can pass a model which can do the resource adequacy piece, as well as the capacity expansion piece to calculate the value of those resources that needs to be able to actually take the loss of load expectation back to the value with the transmission line. The benefit 6, which is mainly related to the weather scenarios, again, any possibility of automation with that type of benefit, it will be a great of a value, because you can imagine, or for those that are PLEXOS users, they know how much time PLEXOS run for one single case. So if we do that for multiple scenarios, that can actually take forever. So any tool that can actually, and PLEXOS has the API tool or the API feature that can actually automate the runs of the PLEXOS, which can help us a lot to reduce the time that is needed to actually achieve or to run the scenarios for benefit 6. As I mentioned, like I'm going to a little bit focus on benefit 6 specifically, because again, it touch base or it has a lot of aspects or good or interesting stuff that you can consider. So the extreme weather events can actually include all of these things, either from a demand perspective, from a renewable perspective, from fuel availability, from generator availability, and from transmission availability as well. With that in mind, we can come up actually with something that, think about it like a double click a little bit, how we can model this and how can we mix this all together to come up with the different scenarios that can be considered. At EPE, actually, we are doing a white paper, which will be actually out soon, for MISO footprint. And for that one, we are actually going to consider the different scenarios for the extreme weather and how actually to implement it to be able to evaluate that benefit 6 altogether. So the last couple of slides I have is mainly focusing on how PLEXOS can help in those benefits altogether. So with the help of PLEXOS, aside from the first benefit, because the first benefit, again, it's mainly focused on thermal overloads, which need to be studied under a tool like PSSE or something that can do steady state analysis. Other than that, all the benefits from 2 to 7 can be calculated or can be evaluated under PLEXOS. And here I'm talking about capabilities of the tool. But still, there is how we will calculate them, that's another layer. Because again, whether are we getting all the values out of it, of the model or not. So for example, the losses one, usually if you extract in production cost modeling in PLEXOS, you get the dispatch of the generators, you get the constraints, but to come up with the losses, you need actually to know the dispatches in the different lines. That is something that can be done, but as an extra layer in PLEXOS, like it's not the normal output. So I'm talking here about the features. Yes, the model has the features, but may not be a normal feature that is being used now under either capacity expansion or PCM. So with that, we can also have last couple of slides, which is touch base a little bit about the main challenges with the FERC 1920 based on the involvement of EPE with multiple either utilities, TSPs, or ISOs. So one of the things that we are struggling is the data availability. So when it comes to the weather modeling, how much data that we have that we can use it to do the weather modeling, for example, for the extreme weather, because under the concept that everybody was using normalized weather before, so how much data that we can go back and how this data can be used to calculate the weather or the scenario modeling for the weather, that's one piece of it. Also the outage data, because most probably in the outage data, you need to build the history of the outages and do maybe some Monte Carlo and Markov chain to come up with some outage scenarios that have certain probabilities to be used to actually model the benefit 5. The idea also, and this is like she in the morning or before the lunch, she touched base on that all the ISOs, they have a mandate about to have this transparent. But actually to have something transparent and as well as it's complex, that's a very hard balance to do, because if it's very complicated and you would like to communicate this to stakeholders is not that easy. And how much you can simplify of the process to make it easier to be able to communicate it to stakeholders, but you are not complying with what FERC wants. So that balance between the complexity of what is being asked and make it transparent and try to make it easy for the clients or the stakeholders, it may not be that much, that balance is very hard. So the last slide that I have here, it's one of the other things that also Plexos can help a lot is basically the repetition. Because most probably we will need to run that model for multiple scenarios. And if we have a tool, as we mentioned before, like the concept of having API and the cloud-based for the Plexos, that can actually do two things for us. Can automate a lot of the stuff and can make things much faster to be able to actually achieve all of that in the short timelines that we have. To conclude, these are the main things that we have. Like so far, still ISOs are working on their compliance, and there is a lot of, again, complexity and sometimes ambiguity and even challenges with how to calculate the benefits for FERC 1920. And again, as we mentioned, that Plexos is very well positioned to do most of that, with the caveat that there is still a lot of things to be discussed from a scenario modeling and the implementation of these features. Thank you so much, everyone. I know I have only 1 minute, so any questions? Yep.
Okay, I think this time I could see from back here, okay. Hi, Mohammed.
Hi.
Great job. I mean, and I think actually you just need to be put in front of policymakers because you explain it really well. I mean, but I do have a question about something that probably everyone in the room understands, but I do not, which is how, and I think you alluded to it, how do you determine how valuable a particular transmission line or substation will be 20 years into the future when the power flows are changing all the time? Is there like a best practice to do that, or a benchmark or something that you guys use all the time? I'm just not familiar.
That's a very, very good question. So one of the things to solve that thing, also it's not my say, it's basically what FERC is suggesting. It will be a rolling window. So it's not one snapshot after 20 years and that's it. It has to be actually rolling windows, and recommendation from FERC that this is actually will be kept repeating every 3 years. So every 3 years, things to be repeated to calculate the value of these things, given the changes in the topology, given the changes in even the modeling techniques that is available at that time as well.